send one person from each group up to get one of each of these? One of each of these per person? Make sure your homework is out. Where's everybody in your group? Oh, they are here. Yep, the calculator worksheet that you had after your quiz on Tuesday.
Good morning, warriors. At this time, will you please rise for the Pledge of Allegiance? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Christian Student Association will meet on Tuesday, December 3rd at 6:45 a.m. in room 294. Frank Club will be meeting on Tuesday, December 3rd at 2:30 in room 296. The club will be meeting.
This is Mary. Who's missing back there, guys?
Please sign up in room 290.
Yeah, but anybody else?
On Wednesday, December 4th, WV Special Olympics basketball will take on Nicosia. We play at 6 p.m. at Nico's main campus in the West. Admission to the game is free. Please come out and support our team as we take on the Wildcats.
Como?
Class of 2015. Are you looking to learn more
Isha?
information about searching for a college but are unsure where to start? Your junior counselors, Mr. Davis and Mrs. Coleman, will be holding informational and interactive sessions with the Super Math College Search from now on for 2 years. Please come to the College and Career Center on Tuesday, December 3rd for the first 25 minutes of your work experience. You will have the opportunity to learn how to begin your journey to explore different colleges and gain the answers to your post-secondary goals. The Warrior Wrestlers play 7th out of the 23 teams this weekend.
Grab your worksheets, hon.
Top finishers were Anthony Napolitano, who placed 7th, Mike Ross, Jack Timberlake, and Tyler Caldwell all placed 5th, and Jimmy Davis and Mitch Cronin earned 2nd place medals. The wrestlers also defeated Mateo Valley on Thursday by a score of 38 to 25 to open the season. Student Council will be having its annual giving tree starting today going into Friday, December 6th. Please deliver unwrapped gifts to the tree in the atrium and deliver gift cards to Mrs. Serpinski in room 350 or Ms. Bretner in room 252. All donations go to Infant Health. Please pause for a moment of silence. Have a musical Monday and go Warriors!
Well, good morning and welcome back. Hope you all had a great break. Good break. Got your worksheet out? So, would you take just a moment to compare the results of your table as we come back to this slide in just a moment, talk about what we're going to be learning about today. We got all positives. This is the actual minus the predicted. Yeah. No, you weren't here. You guys okay? We'll help walk her through that. Yep. If you're doing actual minus predicted, and this is your actual.
So we just, a little confused why we use the linear regression.
Oh, you're going to talk about that in just a moment. Okay, I ask you to take this data and to find a best fitting linear model. Jack's already brought up at a good point that I'm going to ask him to bring up in just a little while. what are your predicted y values from our model? Annie, what'd you get?
19.6, 14.3, 9, 3.7, negative 1.6.
So was the actual value above or below? Jose, can you tell me? This is our actual, if I didn't maybe make that as clear as I could have.
The first one is above, the next three are below, and the last is above.
And then give me the difference between the actual and the predicted, Andrew.
2.4, 1.3, 2, 1.7, and 2.6.
Okay, any questions, comments?
Yeah, I had negative values for negative 1.3.
Oh.
I had negative 1.3, negative 2, and negative 1.7.
Okay, so he says he has negative here. How many of you made those negative? Okay, indeed that's what you want to do, because if you're subtracting, according to the definition of a residual, it is the difference between the actual and the predicted. Does that correlate to anything else in the table then? Oops, thank you. Bing. Yep.
If it's a negative, then it's below the actual.
Yes.
Get predicted.
I hope that you noticed these that were below are negatives. And then you made a sketch, which I'm going to do real quickly for you. We're looking at 1, 2, 3, 4, 5, 2.4, negative 1.3, a real quick sketch, negative 2, negative 1.7, and 2.6. And that's what our residual plot should look like. Okay, so today what we're going to attempt to do is to find some models for data. We're going to actually find a linear, an exponential, a logarithmic, and a power model for 4 different sets of data. And then we're going to determine which of those models is most appropriate by looking at 2 different things. The residual plot, which is what we have here on the right. This is what's called my residual plot. And another criteria today we're going to learn about is the value of R, which you might have seen in another class. And then finally, we're going to put the context of the situation into play. We may not do that until tomorrow. I'm really wanting you to make sense of R and the residual plot today. Sometimes the context might give that away a little bit too much. We'll see how that goes. How many of you traveled over the holiday? Okay, how far did you go?
Minnesota.
How many miles? Or how many hours did it take you?
It's like 6. What did you guys?
6 hours? Anybody go further than that? Oh, how far did you go?
I went to ECU.
Did you drive?
Yeah.
Oh, how long did that take you?
For like
12 hours. Okay, so we have a relationship that we know distance is equal to rate times time. And what kind of relationship is that, by the way? Would that be linear, exponential, logarithmic? What was our first one? Our last one, power? What would that be? Linear, great. Okay, so it's linear. So if we were to actually record some data, where we would say time and distance, maybe after 1 hour, I don't know, how far do you think you might have gone after 1 hour?
I don't know. 60, 70 miles.
60, 70 miles an hour. Let's hope that you're not speeding. We're going to put you under the speed limit, going 60 miles an hour. I guess it depends upon what state you're in. If I were going to, is it realistic that we would continue at that exact rate throughout our trip? So maybe at the end of second hour, we looked at 2 hours, we looked to see how far we'd travel. Maybe we've gone 115. The end of 3 hours, oh, we are on a nice straight stretch, no traffic. we've gone, let's see, I want to put 60, maybe 180. We speed it up just a little bit. So there would be some variability. Maybe we're going to be at 247. 5, we're going to be at 310. Although this model, if our rate was constant at 60 miles per hour, when we're looking at the data, we might use this to model this situation, but our data might not fit it perfectly. And that's what we're going to be looking at today, where we have data that doesn't fit this relationship exactly as we expect it, but we're going to find the best fitting model that we can. So if I were to plot this data, would you put that in your calculator real quick? You know what I'm looking for? 1, 2, 3, 4, 5 here. Oops, not 45. Let's see how good this is. $60, $115, $180, $247, $310. Set up our stat plot. List 1, list 2. Go to y equals, make sure there's nothing there. But what we're going to do is we're going to actually put in this distance equals 60t as our model, or 60x. And I'm going to do a zoom 9. Now, if I trace at x equals 1, I'm right on the line. X equals 2, if I look at the table for x equals 2, my value of 115, I'm looking at the table now, not the statistical list, is at 120. So this actual data value is below. So would my residual value be above or not above or below? Would my residual value be positive or negative? Negative. When I'm at 3, I'm right on. What about at 4? Above. So this is going to be positive. And 310 is going to be above, again, or positive. Would I expect that kind of variability between what my equation suggests and what my actual data is? Or would I expect it to fall right on the line? Sorry? You would expect this. But what kind of variability? Would I always expect my actual values to be above the line, below the line? Would I expect some kind of pattern? What do you think? What are your thoughts? Riley?
I think it would just be random.
You think it would just be random? Okay, so what are we describing now is we're talking about the residuals. The difference between the actual and the expected, he's saying, should be random. Why do you think they would be random?
Because the data is sort of, the data can be affected in many ways, so there's no like pattern to it.
Anybody want to counter that or support that? Rochelle?
Well, I think that's true, but on a case-by-case basis, I think depending on the various situations, you could predict it, or it could.
But if we're comparing the actual data to what our model suggests, do you expect there to be a pattern, or would you expect the variability to be random? Chris?
I think it'd be random because if there was a pattern, then the line of best fit would be changed because it
Okay.
wouldn't fit anymore.
You guys are thinking in the right direction. That's what we're going to look at today. You guys may be further ahead than I anticipated. So those are the things that I want us to think about. Couple other, before we get going, though, we need to look at some things that you may or not be familiar with on your calculator. We're going to be working with a linear regression, the natural log, logarithmic regression. This is not linear. ln means natural log. The exponential regression and the power regression. Now, which of these equations here is a linear equation? Y equals ax plus b, and that is actually the form that your calculator is going to output it. Instead of a slope being denoted by m, it's going to note it as an a. Which one of those would be the natural log regression equation? Yeah? Janessa, which one? The last one. Which one is the exponential? Bing, which one's the exponential?
Y equals AB to I.
And then we've got this one left as our power. Okay. So as we work through the problems that we're going to look at today, we're going to make conjectures. We have not yet talked about the value of r. We're going to make conjectures about the value of r, the role of the residual plot. Again, keep in mind that it is specific to being defined as actual minus expected. And I want you to be thinking about how each of these can assist you in determining the most appropriate model. We're going to do this first one together. If you would enter the data. Please make sure you've cleared that equation out of y1. Yep. Y equals a times b to the x. Yep, that's it. No, it's a x. Oh no, ab, I'm sorry. A times x to the b, the power is. Yeah, a times x to the b. Yep, there you go. Okay, you've got your equation out of y equals. Okay, we're going to work through the first one together. So we're going to go to, that green sheet actually has got step-by-step for you when you get home tonight if you need refresher, but honestly, by the time you get done doing this as many times as we're going to do it today, you'll be really comfortable. Oh, I have to tell you one other thing. Diagnostics have to be on, so you're going to need to go to second catalog. Scroll down. Till you get to the command diagnostics on. Hit enter. Hit enter one more time until it says done. Anybody need help with that?
All the way down.
Way down there. Anybody need help with that? You guys okay back there? Okay, so we're going to start by doing a linear model. And we're going to tell the calculator that we're going to let the x values be in list 1, the y values be in list 2, and we're going to put this regression equation in y1. So now you're going to go to vars, y-vars, function y1, and I think we've done that before, haven't we? Some of you have a different operating system that's going to create something a little bit different. Okay, so we're going to write down that equation. Y is equal to 29.4 x minus 36.2. R I'm going to record as 0.994. Right, what you see on your screen. Exactly. You did you do that with me? Stat, calculate, number 4, this one. Oh, here, we're gonna get those back then. Okay, so we're gonna put list 3 here and list 4 here. Okay? So yours will. Anybody else delete their list accidentally and need to know how to get them back? Okay, now we're going to do a zoom 9, and I should see that linear equation go through the data. Yes?
Which linear regression do we use?
4. Yep. Because you don't have this set up correctly. You don't have it set up as a scatter plot. There you go. Anybody else have questions? Okay, I'm going to show you one more thing that I don't think you've done yet. Every single time you do a regression on your calculator, you get those residual values. Like I had you calculate on that worksheet, that last column with those residual values, it does it automatically for you. So we're going to change our graph, our scatter plot, to compare the x values to the residual values, which you're going to find by doing second stat, that accesses the list, and then find the list named resid. Hit enter. Go back to y equals, clear that out. And then do a zoom 9 again. And then I want you to sketch that residual plot. And then I didn't want to do that. Now, I'm saying sketch. Sketch. Quick. Anybody have any impressions that they want to offer about whether or not this linear model is appropriate for this set of data based upon what we've looked at so far? Jose, you look like you've got something on your mind.
Yeah, well, I mean, it doesn't look like the residuals are like exactly that random, so I don't think the linear model would be a good fit.
Jack? Your thoughts?
Well, before when I said, like, in the graph we did for the homework, it looked more like an exponential decay graph than, like, a linear graph. And it didn't really fit, like, the original data points, but this one seems like it fits the original data points pretty.
Okay, so we've got one saying that this residual plot doesn't appear very random, so I don't think that this linear model is very appropriate. And we've got another saying, well, maybe it is. Can I get somebody to support one or the other? Morgan, what do you think?
I think that it matches pretty well because, like, so I think it's matching, like, they're 2 above, 2 below, and then on this graph they're like 2 above, 2 below the actual line.
Okay, she says there's 2 above, 2 below, 2 above, 2 below. Would we expect that? Tyler?
Yeah, because if you like had found out what the residual value is, like the predicted value is, in the like we did in the homework, and then took the actual minus the predicted, you would be able to figure out that
Exactly. Exactly that same pattern that we found in the homework, only now the calculator's actually done that. This is plotting our x values against those residual values, which is exactly what you just described. But I think what's difficult now is, so we've got this, but there's still some uncertainty. First of all, we have a very small data set. What do we got? 1, 2, 3, 4, 5 points. So maybe we need to compare this model to another model, which is what we're going to do. We're going to find the exponential model for this set of data. We're going to go back to list 1, list 2 in our graph. If you're having trouble keeping up with the calculator, please check with your neighbor. And if they can't help you, please ask me to help you. Now we're going to calculate the exponential equation. Define that in the same way we did. List 1, comma, list 2. Did you get the same thing I got? Okay, so we're going to record that one. Y is equal to 4.4 times 2.03 to the x, and R is equal to 0.996. Whoops, I need to do a zoom 9 again. And I'm going to try to sketch that as best I can to see what that one looks like. Who needs more time? Are you ready? You guys are good. You're doing your residual plot already? Second y equals. Change to that residual plot. Get rid of your equation in y1. And that's what my residual plot looks like this time. Okay, do you think you can do the next one in your groups? The logarithmic and the power, and then we can talk about which one we think is the best?
Yeah. Is it true that as the R value gets closer to 1, the graph gets more accurate?
Is it true that as the R value gets closer to 1, the graph gets more accurate? You were about to say that too. So is that something that you knew from some other class, or you're just making that guess?
No, that was something I knew from another class.
Okay, it is true. So which model now would we go with if we had to make a choice based upon that criteria? The exponential. Who needs help with doing the logarithmic? Who needs help with the calculator? Let me grab this. Yep, you're going to use that natural log one. Let's see what you got.
You know, in chemistry, I mean, not chemistry, physics.
Is the natural log one the LN?
Yep. Okay, you've got the right equation. Make sure everybody in your group has got it.
Yeah.
You've got the right equation. Make sure everybody in your group has it. Somebody got it done already? I want to see the equation. Make sure that everybody in the group's got it. You can probably just. You need a comma. Okay, that's right. You've got it right. Make sure everybody in your group is Recording the same thing? Yours is correct. Make sure everybody in your group is recording the same thing.
What do you guys have?
Yours is good. As long as everybody in their group's got it. Yep, natural log.
Not accurate at all.
Not accurate at all, she says.
It's a 0.97.
Okay, I'm going to record.
0.99.
It's 0.97.
And then for the residual, the quotient is strict to 0.
I'm actually getting this.
If you get that line through your in your graph, just remember to turn off your equation. Okay, who needs more time? Okay, as you guys are finishing up, I'd like you to talk in your groups about which model you think is most appropriate for this set of data. And then what are you basing your criteria on? What do you mean by that?
Like, because it's showing like the distance away from this line.
Okay. Do we want them to be close?
Yeah.
Is that the only thing we talked about? Them being close? And how do you know they're close?
Oh no.
How do you know they're close? Look at it. Okay, how could you do that? Actually, you're going to have to trace them. You have to trace. Yeah. Yeah. Now, is it just that they're close that's important?
Oh, that they're like.
Yeah? What did you tell us earlier? Not just that they're close, or who was that earlier that said that?
It's just that there's like
Some above, some below, and not necessarily in a pattern, correct? Okay, right, random. Okay, what'd you guys decide? Okay, what was your criteria? Okay, how did you know the residual values are close to 0?
Oh, so that's why this one is
Pardon me? Oh, well, so how do you know? I don't see any numbers on that scale. So what can you do?
Oh, there you go.
They're not going to be in the table.
No?
Well, no, you'd have to pull in the residual values. But what can you do? What else can you do? Trace. What about you guys? What did you decide? Power. Your criteria?
The R value was closest to 1, and then it went to like all the
Exactly. How do I know that it didn't go exactly for all the points? Not only that, what else? What else shows me that it didn't go through all the points exactly? Yes, awesome. Great. Okay, can I get everybody back over here, please? Group in the front, what did you choose?
The last one.
The power? Anybody not choose the power? Jason, what was your criteria for choosing the power?
How close it was to 1, or
How-
the R value.
Okay. That was actually the best. They're all very, very good, all 0.99 and above. Oh, no, not the 1. The logarithmic was not. Did anybody look at the residual plot along with that R value? Okay, Jose, what did you think?
I thought that the power one was kind of like the most random.
I also heard a couple other groups talk about the distance. The distance. How could I determine what the distance is from the predicted and the actual value by looking at the residual plot? What can I do with that?
We could look at how close it is to the x-axis.
How close they are to the x-axis, but these all kind of look close. What do I need to do beyond that? Use the trace feature, and I can verify that these are actually very close indeed. We also had another good comment over here about whether or not what the residual plot would look like if this model fit the data perfectly. And I'm gonna see if anybody else can figure it out, because Austin figured it out right away. What would that residual plot look like if the model fit the data perfectly? Ashvini.
It would just be scattered along the x-axis.
All those points would be right on the x-axis, because the difference between the actual and the predicted value would be 0. Well, you indeed are correct. This is the best model. And tomorrow we're going to look at actually what the situation was and talk more in depth about how this is appropriate. The situation was that Tyler dropped a ball from various heights and recorded the time that it took for the ball to hit the ground. The independent variable was time, the dependent variable was distance. You had a question? Gary, you had a question?
Wait, I was going to say that the best fit line also fits perfectly through the dots.
Okay, did you hear what she said? The best fit line fits perfectly through the dots. Agreed? She said this fits perfectly through the dots. Maybe not the way I sketched it. Agreed or no? No, why not?
Because the data, it's not perfect. Like if it is perfect, R value would be just 1.
And
What
then
else would we notice?
The residuals would, or the polynomial.
Go back to what we were just saying. The residuals would all be at 0. It looks pretty good. It does look pretty good, but not quite perfect. Okay? Does that clear that up, Gary? Okay, so we're going to talk more in depth tomorrow about the actual situation and answer some follow-up questions. So I've got another set of data, and I have plotted it for you already. You're going to sketch in your model. You're going to do a linear, an exponential, a logarithmic, and a power. This should go much quicker now that you've had the chance to get comfortable with your calculator. And I'm going to do the residual plots real quick.
What should we use for the x values?
The x values, it's a good question.
Should we use 1?
Looks to me like they're 1980, 1985, 1990, 1995, 2000, 2005. Do you want to use something different?
Yeah.
You do? What do you want to use? 1 through 6. I don't really like 1 through 6.
How about 0, 5, 10?
Jack?
0, 5, 10, 15.
And I prefer that only because if we want to use this model to predict something in between 1980 and 1985, and we start at 1 and go to 2, then that makes that transformation just a little bit more difficult. If you would like to use 0, 5, 10, 15, you may do that. My equation is going to be different than yours, but that's okay because the R value will be the same. I use.
But if you start with x as 0, you're not going to be able to get the logarithms.
We'll talk about that in a little bit. You already figured that one out, huh? How'd you figure that one out?
I tried it out.
Oh, he's way ahead. How about the power? Okay, see what happens. So we made the decision to go 0, 5, 10, and so on. There, you use a 1980 or 1985? Okay. No, it's up to you. Yep.
We're trying to find the best line.
Yep.
Can we just kind of skip the whole graphing part and just look at the R value first for each one?
I want you to make a connection though between the residual plot and the graph and what the line looks through the points. I'm trying to help make you see that, you know, if it's an over prediction, your residual is going to be a positive, and if it's an under prediction, it's going to be, let's see, am I saying that right? If the difference between the actual and the residual, see, like here, look, so this line is an under prediction, I should say. The line under predicts what it actually was. So this residual corresponds to something above this x-axis. And this should be above, and this one is below. And these all actually are somewhat below. Good question. So did you leave yours as 1980? Okay. How many of you have left them at 1980, 1985? Okay, that's fine. Yep. Did you paste it in there when did you do your regression equation?
I did the linear.
Ah, but you got to paste it. You have to tell it to put it in Y1.
You can do it straight from there.
Yeah, where you been doing it from?
I've been just writing it down here and then putting it into Y1.
No. Look at your green sheet. Who else has got questions? Calculator or anything? Okay. R squared is called the coefficient of determination, and it tells us the amount of variability that the regression equation removes. Let's see, how do I want to say that for you? It's a percent of variability that is removed by using the regression equation instead of the mean of y as the predictor. But if you really want to know about R squared, take AP stats.
Do you get a negative?
All of that in AP stats, right, Jose? Are you the only one in here who's?
I think isn't Ashley in it too?
Yeah, you and Ashley, yeah. Anybody else in Ms. Goff's AP stats besides Jose? You should have asked Jose what R squared was. Let's see if he could have told you. You guys doing okay?
Which value?
You did 1, 6.
Yeah.
Yeah, because I just like went up.
You did 1 through 6.
No,
You did 0 to 5.
3, 6, 11, 16. So they like, because it went by 5.
You doing okay? Calculator's being kind to you today?
I did one.
0 wrong.
Are we running into any issues?
0 does not.
Yeah,
You can't take the log of 0.
you can't take the log of 0.
So I just started at 1 and went to 6.
Okay, so or how about if we make this
Well, I did
10, 15, 20, 25, anything other than to get rid of that as a 0.
I did just 1, 6, 11,
Okay,
16.
I got it. I thought you meant 1 through
No.
6.
So if I go back and change it now, because I started at 0, is it going to change by half?
That's a great question.
Like if because now I have to change it for the logarithmic one.
Okay, so what's important here is what's going to happen to R and what's going to happen to your residual plot. It's not this is itself is not important. These are going to change based upon whether you use 1980 or 0 through what was it, 25. The equation itself is going to change, but this R value is going to stay the same. Let me stop and answer a couple questions that have come up that I think is important for you to understand. Someone who used 1980, 1985 throughout, 1980, 1985, the original data. Can you tell me what R is for the linear equation? Okay, who's talking? Because okay, Ashley, go ahead. Negative 0.9? 9. Do you have the third decimal? No. Okay. How about the exponential?
Negative 0.99.
How about this next one?
Negative 0.991.
Oh, decided to go 3 decimals now.
Negative 0.9899.
9899. Okay, somebody who used 0, 5, 10, 15, and so on. Were your R values the same or were they different? Your R values were different.
The first one was not.
It's negative 0.99. Yeah, negative 0.99.
You got different as well.
You got a different log.
You got different. Well, that's surprising. Oh, because of yeah. Okay, so I guess what we're going to have to do is we're going to have to look at what did you use these for these first two and then this change here?
We did 1, 6.
You did 1, 6. Okay, so if you did 1, 6, 11, 16, and so on, how many of you did that? Okay, tell me what your R values were. 0.9 positive?
Yes. Yeah, it was positive.
0.99.
Then negative 0.99.
Yeah.
Might be looking at negative 0.86.
I got a positive 0.86.
Oh yeah, that one's positive.
That one's positive.
And then negative 0.85.
Negative 0.85. Okay, anybody use any different set of numbering than the 1, 6, 11, 16? Well, I'm curious why you got a positive 0.99 here. Can you run that one more time? Your linear. Does anybody know what the relationship is between the positive and negative R values?
It is negative.
It is negative.
There's a 1 at the end of it.
Okay, let's go go back for now and just talk about those who left it as 1980, 1985, and so on. Just looking at R values, which model would you choose? Which model would you choose just looking at R values? Linear? Who said linear? Annie, why?
Because, like, you got negative 0.9913, and that's the closest to
9913. Compared to what did you have for the others?
exponentially had negative 0.9901. Logarithmic, negative 0.9912. And power is the same.
Okay, so just based upon that minute difference in R, you decided that that was the best model. Because that is such a huge difference in R, isn't it? Right?
After rechecking ours, we realized the 0.86 is negative.
I was going to say that should have been. Okay, well, but let's talk about the green one right for now. What about your residual plots? They all look the same, don't they? They're all pretty close. I don't know if you trace them, then you might find some difference in terms of how far they are away. But if I'm going to have to make a choice based upon this, which one would we choose? Who's going to go with linear? Who's going to go with exponential? Logarithmic? Power? And clearly the rest of us are undecided. Well, those of you who chose linear without knowing the context, that would be the best choice, because one of our other criteria, Jose might recall, Ashley might recall, is we would choose the simplest model given that we knew nothing else. And a linear equation is going to be a simpler model than any of the others. And again, this data, the context is that the X value is the number of live births per 1,000 women aged 15 to 44 in the U.S. starting, oh no, those are the Y values, starting in 1980. So the X value is the year, and the Y value is the number of live births for women from 15 to 44. The next two may surprise you somewhat. Some of you already found out that you cannot take the log of 0, as you recall. So you either have to transform the data if it's appropriate, like this group did, or you might just have to delete the values. But your homework tonight is going to be to use these same criteria, the value of R and the residual plot, the randomness of the residual plot, and helping us to choose which model is most appropriate for the data that we have. Tomorrow I'm going to give you the context for the other two as well. So what can somebody summarize the value of R? Gabe. Always to positive 1. Okay, whoa. Whoa. Don't close up yet. We're trying to finish a conversation and I can't hear. Closer it is to positive 1.
Yeah, the better the best fit minus.
Okay, so look at number 2. Positive or negative. And what's the difference? When is it positive versus when is it negative? The slope of the line. With the slope, or as X increases, Y decreases, versus as X increases, Y increases, because remember, we're not always choosing a linear model. And then the residual plot. Again, what are you looking for in your residual plot? How close it is to the x-axis? Is that the only criteria? The randomness of the residual plot is your other criteria. So those are the two things with your residual plot. Nearness to the x-axis, randomness, and your R value.